This video presentation is brought to you by the Pro Mathematics Academy. Welcome to another video presentation brought to you by the Pro Mathematics Academy. In this video, we'll be looking at simultaneous equations, right? And when we talk about simultaneous equations, we're talking about having multiple equations with multiple variables that we're trying to solve for. So in this video, since we'll be looking at simple equations, we will be looking at X and Y only. So we'll define the simultaneous equation process as the process by which we solve for both X and Y that can solve both equations. All right, so here we're looking at two equations. And when we solve simultaneous equations at this level, there are two basic methods that we always look out for, which are the method of elimination and the method of substitution. In this video, we'll be looking at the method of elimination only. Check out part 2 for the method of substitution, right? So we move right along to talk about the simple linear system, right? And when we talk about the simple linear system, we're basically talking about equations of this form, whereby we have ax plus by equals to d, right? And this is our first equation, right? And we have cx plus dy equals to e, right here as equation number 2. So when we talk about A is the coefficient of X and B is the coefficient of Y for equation number 1, and C is the coefficient of X and D is the coefficient of Y for equation number 2. These terms here are referred to as our constant terms. Okay, and the important thing we want to note here is that when solving by method of elimination, we want to, here this is supposed to be off. When solving by method of elimination, we want the coefficient of X to be the same in order to eliminate X, and we want the coefficients of Y to be the same in order to eliminate Y. So this is the general process which we will follow when trying to perform the method of elimination. Okay, so without further ado, I jump right into some examples. Here I have example number 1 for us, right? And it says solve the following systems of equations by method of elimination. So without further ado, I observe this equation and I realize that the coefficient of X is actually 1 and the coefficient of Y is 1 for equation number 1. So let's label our equations. That's the first thing we want to do. So this is equation number 1, this is equation number 2, right? And we see that the coefficient of X and the coefficient of Y are both 1 in equation number 1. For equation number 2, we see that the coefficient of X, right, is 2 and the coefficient of Y is -1. So let's eliminate Y, right? And we want to eliminate Y by doing what? By adding both equation number 1 and equation number 2, right? So if I add both equation number 1 and equation number 2, here I realize that the coefficients of Y are negative and positive. So if I add them, I will end up with 0. Thus, we have eliminated Y from the equation, right? So if I add the terms in X here, we have X plus 2X because I'm adding both equation number 1 and 2. So X plus 2X is equal to 3X. So let's put that down. And I'm adding Y plus a -Y equals 3 plus 8. So if I simplify this, this gives me 3X plus 0 is equal to 11, which means I can transpose for X, which means X is equal to 11 divided by 3. Thus, we have eliminated Y and we have allowed ourselves to solve for X. Now I'm going to eliminate X and solve for Y. So if I take the same system of equation, X plus Y equals 3 as equation number 1, and 2X minus Y as equation number 2 equals 8, of course. I can eliminate X, but only if the coefficients of X are the same. So here I have coefficient of X for equation number 1 being 1. So in order to make the coefficients the same, I'm going to multiply equation number 1 by 2. So that means I multiply each and every term in the equation by 2. Okay? So let's write that down. So we now get 2X plus 2Y equals 2 times 3, which is 6. And we write this as our new equation number 1, but our old equation number 2 stays the same, 2x minus y equals 8. But now, if you notice, we have the coefficients of x being the same in both equations. So now, in order to eliminate x, I'm going to take equation number 1, and I'm going to subtract equation number 2. This then gives me 2x, take away 2x, right, plus 2y, take away a negative y, equals 6 take away 8. So each and every term has to subtract each other. So here 2x takes away 2x, 2y takes away a negative y, and a 6 takes away a 8. Okay? So simplifying this gives us 2x minus 2x is 0 plus 2y minus y. Whenever we have two signs juxtaposed like this, we end up with a positive. All right, so once a negative and a negative is juxtaposed, we end up with a positive. If a positive and a positive is juxtaposed, we end up with a positive. But if a negative and a positive sign are juxtaposed, then we end up with a negative. So here, this gives me 2y plus y equals 6 take away 8 is equal to negative 2, which now means that we can take our 3y and we can equate that to negative 2, which means that if I transpose for y, I end up with negative 2 divided by 3, and thus we have solved for both x and y. So, how do we know that these answers are correct? What we can always do is to check, right? So here, checking equation 1. Equation 1 was x plus y equals 3. So this means if I take my x value, which was 11 over 3, and I add to that a negative 2 over 3, right? This is equal to 11 over 3 minus 2 over 3, which is equal to 11 minus 2, all divided by 3, which is the same as 9 divided by 3, which is equal to 3. So therefore, we already knew from equation number 1 that the answer should have been 3, right? Once I add my x and my y. So therefore, these values that we just solved for works for equation number 1, right? But how do we know if they work for equation number 2? We have to check as well. So let's check equation number 2. We see equation number 2 was 2x minus y equals 8. So here, I take my 2 and I multiply by 11 over 3. And now I subtract my negative 2 over 3. And I want to see if when I simplify this expression, I will end up with the number 8. If I do, then that means x equals 11 over 3 and y equals negative 2 over 3 is the pair of answers that solve both equations, which means we have solved the equations simultaneously. Okay, so continuing, this gives me 22 over 3. Once a constant term is multiplying a fraction, right, that constant only multiplies the numerator, okay? So this then gives me 22 over 3 plus 2 over 3, which if I add 22 plus 2, all divided by 3, this becomes 24 over 3, which is equal to 8. Therefore, my new conclusion is that this not only solves equation 1, but x equals 11 over 3 and y equals negative 2 over 3 solves the system of equations. So whenever we work out our answers for simultaneous equations, we should be able to plug them back into the system of equations, and it should solve each and every equation in the system. Therefore, our answer would be correct. That is it for this video. Please remember to hit the notification bell, like, share, and subscribe for future post notification.